Now I would like to have a look at page 152, where we have the exercises of 9E.2, exercises 1, 2 and 3. And to help you a little bit getting started, I would like to make some remarks about question number 2 and 3. Now question number 2 has a set with the elements 1, negative half plus I square root 3 divided by 2 and negative half minus I square root 3 divided by 2, and the multiplication is the operator I'm looking at, and the other set has the elements 1, 2 and 4 also with the same operator. So this is one group and this is one group. Now first of all, here if you look at the Cayley table, you have of course this element negative half plus I square root 3 divided by 2, negative half plus I square root 3 divided by 2. And if you want to know this answer, then it goes like this. Obviously you have this times and if you calculate it, negative half times negative half gives me a quarter. This gives me plus I square root 3 divided by 2 times a half, but here I have the other one, so this gives me an entire I square root 3 divided by 2, but obviously this needs to be a minus, sorry. And then the last multiplication, it gives me I times I gives me negative 1 times square root 3 times square root 3 gives me 3 divided by 4. So this gives me 1/4 minus I square root 3 divided by 2 minus 3/4, or in other words, this being the last element of the set I'm talking about. Now what they do in the answer back in the book, they simply say, well, look, this element I call alpha, and then I know this element is simply alpha squared, and they make a Cayley table using those two. Okay, so try this for yourself and see if you can find out the answer. Then question number 3, they are talking about the fifth root of unity. Now unity, of course, being 1, because the operation is multiplication, then I have the fifth root of 1 not necessarily being 1, because we're talking about unity, not 1. So what they do, they call this alpha. Then the next fifth square is this one, calling it alpha squared, and so on, and obviously the last one being this. And then use these alphas and the powers of alphas to answer the question.